we'll talk more about the fact that you can drive that processing to where the data is. So you don't lose time moving data to your processing. The fourth thing, and this is absolutely key, and it was unique to Google, the rest of the world is catching up on it, is the idea of reliability as an engineering discipline. If you are going to attempt to provide services to people online, you're going to have to approach it as an engineering problem. Google did. Google has an entire branch of people called SREs, and these people are the commandos of making stuff, work. And then they wrote a handbook, which is available. I think it's published through O'Reilly. You can order it on the other company. It's also free. By the way, my very favorite price, free. It's online, in your cloud journey. There are few things that will guide you better than the insights of people who've had to make this stuff work day in, day out. And Google's providing that for free. So as we go through today, there's a range of computing architectures. On the left-hand side is the do-it-yourself. Here's mud, here's water, make bricks. There is a very good reason why, in many situations, why you would do that. On the right-hand side is Google already figured it out. Google has invented the wheel, it ain't gonna get rounder. So spend your time working on the applications that leverage the wheel. Again, your choice as engineers, or your job as engineers, is to evaluate the situation and align your tool choice with what best drives the solution. So you have this wide range of capabilities that Google offers you. We talked about the Google network. I like to throw it up there just because I think undersea cables are freaking cool. There was a show, there's a Great Ships program that shows on the History Channel. Believe it or not, the History Channel shows something other than World War II stuff. But they had an entire show about this ship. There's two of them that lay cable. And they went through the process of laying cable to Panama. These two ships have been booked solidly for years. The cables that you see here, Google either owns outright or has a majority investment in. So Google realized how critical the network was and made the investments. And many of these investments are over 10 years old. So the realization from day one that data would have to be scattered around the world, yet instantly accessible, is key to Google's DNA. Now, as mentioned before, Google has locations throughout the world. Your choice in determining which region is kind of a complicated one. Obviously, you would like it to be closest to your customers, but less obviously, there's a lot of data governance rules. You may or may not know this, but if you have customers in the EU, if you accidentally move information about your customers in the European Union to the United States, it's a 1,000 euro per incident fine, and an incident being an individual customer record. So if you accidentally copy a 1 million user database from Dublin to Virginia, that's €1 billion. That will get you talked about. So regions not only represent the capability of being closer to our system, but giving us protection at a regulatory level. Also giving us protection in sort of a disaster recovery set. You know, I'm from Oregon, by the way. I knew which picture that was. Did you see mountains? That's Oregon. Did you not see mountains? That's South Carolina. Okay. Sorry, they put when you move to Oregon, they put a chip in you. You have to, and then from then on, Oregon rules. So you're choosing your regions based on locality, based on data governance, and in some cases, capabilities. You know, we can't instantaneously roll out technology to every region at once. So your choice as engineers is which regions you're going to put stuff in. Now, here's some really cool stuff you can take to the CFO. As Omar mentioned earlier, there's discounts that happen automatically. Use it more, pay less. That's pretty cool. But even better, if you don't use it, you don't pay for it. I am the oldest of 5 boys. Okay, say it all together. Your poor mother. But I still hear my dad's voice ringing in my head. When you leave the room, turn off the lights. The couch is not watching the TV. Why is the couch the only one in the room watching the TV? You have to think in the cloud the same way. When you're done with it, turn it off. And Google led the way in saying, you know what? We'll let you do that. And we won't charge you an hour's worth, we'll charge you by the second. When you turn a machine on in Google, you're charged for the first minute, and then it's per second after that. You're done with it, you're done with it, turn it off. And that idiot engineer who spent $8 forgot to turn something off. By the way, I wrote a script, so it's automated now. And then finally, Omar also talked about the fact you can align the actual VMs with your CPU needs, with your local storage needs, with your memory needs. You can customize it. Okay, the other thing that isn't necessarily apparent, it was from day one, when you interacted with Google as long as I have, you've always known this, but maybe people need to be reminded about it. Google has always been open source. And I used to do this thing where you'd meet with a senior level manager and they're like, I'll never use Linux. Linux is completely unreliable. I'm gonna Google something to show you that. You know Google runs on Linux, right? So from day one, Larry and Sergey have been part of the open source community and have contributed back to it. You saw the fact that Hadoop is based on a paper from Google. You saw the fact that Apache Beam was actually released from Google. TensorFlow has been released in an open source project. TensorFlow is one of the most committed repositories in GitHub. Kubernetes used to be called Borg when it was inside of Google, which I think is a much cooler name, but a little on the nose. So Kubernetes got released, and now it's its own standalone project being developed by thousands of volunteers, in addition to thousands of resources from Google. Google believes in open source because that's their business. You know, they have the track record of doing it. Okay, the other thing, and Omar was, he's totally right about security, totally right about the layers. But, you know, Google isn't perfect. There was a big surprise when Edward Snowden released his memos. The surprise was the NSA was inside Google. And that was a gigantic surprise. And I think within a week, Google had converted every transaction inside of Google occurs over SSL now. Every disk is encrypted. So you literally have to break the encryption out. You have to remove the encryption yourself to get this. So when he talked about the fact that Google has thousands of people, I spoke with a bank earlier, and they're like, oh, we have an enormous security department. There are 40 people back there. There are 40 people working on security in Portland. I have no idea how many people are working up the road here in Mountain View. There's literally no way anyone else other than a cloud provider can amortize the cost of these resources. So that's what you're competing against, and that's what you should leverage. So why should you choose the Google Cloud Platform? Well, 2 things. I told you my favorite price, right? What's my favorite price? Exactly. The other thing is I have to tell you something. I'm lazy. I don't like doing work I don't have to. The other thing is I'm not as smart as the people at Google. I'm just saying right now. I'm not going to be able to design a database or networking better than they are, but if they're going to let me use it and charge me 12 cents an hour to do it, I'm going to do that and focus on my product. So that's the perspective I would like you to have. As engineers, you're looking at these tools, at the cost of these tools, the capability of these tools, and you're making choices. So, range of compute services available, all the way from run the VMs yourself to there's no VM at all, Cloud Functions. You just write some node.js and a miracle occurs and it runs. We'll talk more about the miracle. Storage, the capability of throwing millions of transactions per second of your storage facility. We will look at a case study where a big table is capturing in real time every transaction occurring at the New York Stock Exchange. All the way to something like Cloud SQL, MySQL or Postgres. Then the big data, BigQuery, as Omar mentioned earlier. PubSub. PubSub is the background to Google. PubSub is you push data into PubSub, and then the data gets either published outward or queried by systems. This data can be in up to 10 megabyte chunks. This is how the internet travels inside of Google. When Google's doing its scraping, all those scrapers are pushing it into PubSub. And then the people that need to update their databases, or processes that need to update their databases, read PubSub. The internet travels across PubSub inside of Google 8 times a day. All the trackers, all the scrapers for Google refresh themselves at least 8 times a day through PubSub. It can handle your queue. And then machine learning. So, quick quiz. What are some of Google Platform's pricing innovations? I heard per second.
Free.
Yep, and then by time?
Free if you don't use it.
Yep. Preemptible. Heard that too?
Free if you don't use it.
Yes. Pay only for what you use. That's key. By the way, if your IT function now is only using what it needs, and what it needs to do is a function for the rest of the company, maybe IT becomes a profit center instead of a cost center. When you save $1, that dollar appears as profit. When you make $1, only the amount of your profit margin gets there. So if you have a profit margin of 20%, an extra $1 in sales, it may end up being 20 cents in profit. But if you save $1, that's $1 in profit. This is a discussion one needs to have with one's bosses about how you're delivering profitability. Okay, what are some of the other benefits of Google Cloud Platform other than pricing?
It's free. Free.
Yep, absolutely.
Security.
Security, absolutely. Environmental responsibility, because that was not a slide that I had. You have to remember back to Omar's. By the way, you can always tell when the slide was written by marketing, right? We'll get to some engineering slides later.
Encryption.
Okay, so resources here. Your resources, the everything starts with cloud.google.com. You want to look at PubSub, it'd be cloud.google.com, PubSub. You want to look at BigQuery, cloud.google.com/BigQuery. So that's your URL. Oh, and by the way, this is, as mentioned before, you fill out a survey, give us a screenshot of you filling out the survey at the end of the day, you get a t-shirt. And really, what's the purpose of being here other than getting a t-shirt, right? What are you gonna wear to wash the car next year? Okay. So let's talk about some of the basics, the infrastructure we need to make sure that we're using this correctly. What we're going to do is we're going to start with foundational stuff and then build up to the really cool stuff at the end. Why? Because otherwise you'd fall asleep at the end. So we're going to talk about the security here. We're going to talk about manipulating everything. But I want you to walk in with an idea of what you need to do. And this graph is great for that. If you are running the systems yourself, you have to do everything, particularly in security. You know, you have to make sure that there's identification systems, authentication to physically get in. You have to make sure that the cables are armored so people have no access to it. You have to be sure that the operating systems are the correct image. You have to be sure about the storage being encrypted. So there's layers upon layers of stuff that you have to be sure of. And you have to be right 100% of the time. In order for something to go wrong, It only has to be you being wrong 1% of the time. If you're wrong 1% of the time, that means 3 days out of the year you're vulnerable. So how does that make you feel? A little challenged? What if you dump that on other people? What if you dump that on people who say, we've got thousands of security people, and we've got a track record of defending ourselves against state actors, against large political movements. I mean, just think about some of the bad people out there, how big a target Google is, and how much Google has to defend itself. So with the infrastructure as a service, then you get a lot more stuff covered for you. With platform as a service, where you're actually just using software and running it, you have no insight into things like the operating system. And then managed services. So this is something that should factor into your decision matrix as well. How much resources are you going to necessarily put in to guarantee the level of security required? How many people here work in PCI regulated industries? How many people here in HIPAA? How many people want me to explain PCI and HIPAA? That's another class. Okay. So, how does Google protect this? What's kind of the metaphor we can use to get our minds around how Google protects things? Well, what Google has is what we call a resource hierarchy. It's a hierarchy that says there's a thing that owns things. We'll call this thing an organization. Maybe the organization that pays bills, like for my software company, we'll see it during my demo. I'll show you the organizational node. When you create your own account, you are, wow, we really need to do GCP, and my boss isn't looking, here's my credit card, sign up for an account. And then suddenly the auditors come along and say, who's in control of this? There's a lot of bad things that happen with that. With something like an organizational concept, Google will look at that and go, well, this is part of an organization that I recognize. I will fold this manager's project into the organization itself. We'll have a consistent security policy. So below the company level, we have the concept of folders. Below that, folders are just a way of organizing things, as they are with normal manila folders. And below that, we have projects. Projects are the actual things that hold resources. They actually hold on to things like your VM that you started belongs to a project. Your BigQuery belongs to a project. So it is a way to establish ownership, a granular level for security. It is also the way you get billed. So going back to here, you are not, when we talked about, there's things like quotas and free levels. With projects, you have a free level that applies to every project. So here's something you should not do. Do not create a brand new project in order to prototype a brand new product so that you get the free level and don't pay anything while you're prototyping the project. Am I clear? Okay, that would be bad. So projects own things, they pay for things, and they allow you to also have granular control over who can get into stuff. So let's say we have a dev project. That's where our code is. And our dev project says, well, we are done. They now have an object in the source code control that they can broadcast or they can publish to the QA project. And the QA project can inherit the code and run it in their own environment, thus stress testing it. And then when QA is done, they can move it over to production. So you are automatically testing things like dependencies. Have you packaged it correctly? I'm sure this has never happened to anybody, that when dev pushes a product out to production and suddenly it collapses, and you have this meeting where developers are sitting on one side of the table, production sitting on the other side of the table, and developers say, it ran fine on my machine. I've been known to fling myself across the table, grab their machine, and threaten to put it into production. What we need to do, obviously, is we need to stress this during our process, and projects are a great way of doing that. Then the projects themselves can be collected into folders. So we have a product. Let's say we have the FooBar product. And the FooBar product has a dev project, a QA project, and a production project. Now we can hold all these things together. We can create consistent security footprints. Let's say that this is an audited project, and the auditors want to see things like role separation. You know, people who create the database can't add to the database. You can create those rules at the folder level. And then at the organizational level, you have people who can control whether people can access what's going on with the project. The organizational level has 2 people in it. Right now it's Bob and Alice. Bob is the organizational admin, and he can create project creators. Alice is a project creator, and she can create projects. So this might be CTO directors, or head of engineering managers, so that you have a single point of contact or a single point of responsibility. By the way, don't make it a single point. You know, what happens if Bob gets hit by a bus? And what is it about buses? Why are they always hitting people who are critical? You might want to think about having to, Bob doesn't watch, he texts while he walks, so back it up with Carol. So this is the level where the organization itself can authorize access, can authorize creation of resources. All this is controlled in something called the Identity and Access Management System. How many people here are familiar with AWS? Okay, and keep your hands up if you've used IAM in AWS. Okay, this is IAM in Google Cloud is similar to AWS IAM except for the I. In AWS IAM, that's where you create users and groups and such. In Google Cloud IAM, the user or group is created external. So you have the ability to create external identities and map those identities into the Google Cloud. So you don't have to have them be in this separate walled off area. So other than that, they're pretty much the same. They control permissions, etc. So identity and access management, it controls who can do what on which resource. So as I mentioned, identities are not created in Google Cloud IAM. They come from the outside world. They can be a Google account. So if you want to, my Gmail account is john.gallagher@gmail.com. I can create a Google Cloud from that. My software company is Nube Dialato. So John at Nube Dialato is my account inside of my company's GCP account. So based on that whichever email address, whether it's a G Suite email address, Gmail email address, if your company is like Active Directory, it doesn't use G Suite, we'll talk about that later. You can map your identities into a Google group. And if these identities are in a Google group, they can inherit. So that takes care of the who. And then we have what are called roles. Again, this is a little bit confusing between AWS IAM and Google Cloud IAM, because roles in AWS IAM are a type of identity. In Google Cloud, roles are what roles are traditionally in security, which is a list of permissions that someone is allowed to use. So, in the 3 types of roles, sorry, I brought a little Portland with me. The 3 types of role are a primitive role, a predefined role, or your ability to create a matrix of permissions entirely on your own. By the way, the beta flag here, it's custom roles have been generally available now since January 31st. That is one thing about the cloud, is there were over 700 product updates, changes, and new releases for Google Cloud last year. And that's over 3 per business day. Sorry, it's going really fast. So a primitive role is basically like root in Linux or administrator in Windows. It is root can do anything. Well, a primitive GCP IAM role equivalent to that would be owner. Since you own it, you can do anything. There's no limitations on your permission set. There are 3 different kinds of primitives: owner, editor, and viewer. So viewer has read-only access. It's what you would give to a logging facility or an auditor. And the editor can do anything except change permissions and add new people. And an owner can do everything. Then Google realized, there's one other person we need to add. The CFO may want to take a look and see how much to write the check for. So they added billing administrator. So these are called primitive roles because they are a universal way of saying, within this project, Susan can do this. She's an editor, she can just do it. You can also get more finely grained by taking predefined roles and applying them to an identity. You might say, Linda is in charge of our VMs. We don't want Linda to change anything about our buckets. We don't want Linda to do anything with our, thank you. We don't want her to use BigQuery. We're going to just give her only permissions to manipulate VMs. So GCP has a set of permissions that can do read-only access, that can do manipulate access, that are all predefined. So you could create this instance admin role and assign all these predefined roles to it. Instance delete, get, list, etc. Assign that to Linda, assign it to a Google group. So this could be your VM admin group. And they inherit these permissions. But let's say that you didn't want all those permissions for somebody. So the instance admin is a predefined role. Let's say we only wanted to let someone start and stop, but not delete VMs. In order to do that, what we do is create our own custom role and give them a more limited set of permissions. So this is the custom set of permissions that are now generally available. So, as I mentioned, we know how to track people. Typically, everyone's got an email address. There's some Active Directory or some sort of directory. We give the machine an identity. It's called a service account. And we say, here's a service account, and we attach permissions to that service account. Then we attach the service account to the machine. This allows any program that's using the GCP SDK to inherit permissions. So what that allows us to do is, remember instance admin? We can create a service account and say the service account inherits the instance admin role, and now our compute instances can manipulate other compute instances. Interestingly, we can also use this with people. Now, those of you who from the Linux community, you're probably familiar with sudo. On a daily basis, you do not log in as root. That's just dumb. You want to be protected from your fat fingers. Literally, these are fat fingers. So I log in as John. But if I need to mount a disk, if I need to add a new user, I need higher level permissions. So I'm going to run sudo. Sudo is a command that says, okay, for the X period of time, you have a higher level of permissions, maybe root-like permissions, you can run the command. Service accounts work the same way. You can establish a service account that has a higher level of permission than, let's say, the user group on the left-hand side here. Let's say that this is Jerry on the lower left-hand side. Jerry, on a day-to-day basis, does not have the ability to create buckets. But Jerry wants to create a bucket, so Jerry runs a command saying, allow me to become this service actor. If Jerry has permission to run that API call, then Jerry can be promoted to the service actor for a specified period of time, between 15 minutes or however long you want. So Jerry has these higher level permissions. Jerry can do his or her job and then drop down to normal permissions. So you are not locked in. You don't have to say, well, I'm going to have to give Jerry all these permissions because Jerry may or may not need to create buckets. No, you give Jerry their normal day-to-day permissions, and then you allow Jerry to become a service actor. As an example here, we have Project A. On the top level, we have components that are operating as Service Actor 1. They have been given editor permissions to those resources over in Project B. So think of this as maybe these are administrative machines that need to do stuff for logging. They're allowed to manipulate those machines. Meanwhile, Service Account 2 is only allowed to look at that bucket 1. So we can create different service accounts running on different machines and have them doing privileged stuff in a traceable way. So how do we get to this point where we can manipulate this stuff? How do we interact with the cloud platform? Well, there's 4 basic ways. Today, in the demos and such, we'll be showing the console. The console is basically a GUI, web-based interface, runs on any browser. Meant to be a centralized console for your data, along with developer tools. You'll see on some of the demos that the console includes an SSH, includes its own virtual machine to run stuff. There's also the Cloud SDK, which includes a command line interface. How many people here code in shell script? Linux admins, right? I'm lazy. Remember I said I'm lazy? I've been a Linux admin for far too long. I know that if I'm going to do one command today, I'll probably have to do it again tomorrow, so I just write a shell script. So the command line is meant for people like us. If you can put it in a programmable shell, it becomes a program itself. The SDK is also available as a Docker image, so if it isn't ported to your machine, you have it available. All the APIs that manipulate Google Cloud are accessed via REST. So if you're feeling particularly bored, you can manipulate it all through curl. And please get a life. And then finally, of course, there's an app for it. Meanwhile, one thing we haven't mentioned is that Google itself is this wealth of other APIs. How many people use the Map API? Seriously? Any AdWords API? Really? Okay. So Google has all these other APIs that are not necessarily part of Google Cloud, but you might want to bring them into your project. You do that through the API Explorer. You say, yeah, I want to use the map, or I want to use geocoding. Turn on the API Explorer. You're ready to go. And then finally, there are libraries supporting common languages, Go, Node, JS, Dart, Objective-C. There are also people coding things like Rust. I think there's an Erlang. Libraries that allow you to use languages to manipulate this. And then finally, this can all be packaged up into what we call Cloud Launcher. What Cloud Launcher does is pull all the interactions necessary to do the things we want to do with cloud through what we call the deployment manager. Once you have it packaged up in the deployment manager, you can then publish it through Cloud Launcher and say, hey, I'm selling my software. Press this button. And when the user presses the button, automatic deployment of your software. So with that, what I'd like to do is bring out a whole team of folks to take us through some quizzes here and through some questions. So there are mics available in the center aisles here, and we'll be bringing up the house lights. And then after we get done with this, we'll head off to lunch. Oops, wrong button. So, come on out. Oh, I'm sorry. No, I got it wrong. Sorry. Corey's gonna kill me. We're gonna have a demo from Corey Peel. Ah, I'm so sorry.
take a look at some of the things we were talking about a little bit earlier today. So as I get my screen ready, we'll be projecting. And so you heard a little bit about identity and access management. You also heard how we're able to easily provision solutions using Cloud Launcher. So today I'm going to go over the navigation of the Cloud Console briefly, and then I'm going to do some live deployments of a couple of different applications. So let's just get right into it. So if you're going to the cloud.google.com site, you can log into your console, and as a user with access, you're able to see the different options in terms of navigation. So the top left has your main menu, and so you're able to go through and see some of the core items you would need to work on in terms of setting up identity and access management. You also have a list of our core services. We have these categorized. So for compute, also storage, networking, those of you doing hybrid clouds and some others may be of interest when you're looking into that. Monitoring, and then other tools. So those of you in the room who are responsible for managing the infrastructure and making sure you have the appropriate setup when you go from dev, test to prod, these tools are important to you. And also if you're a developer deploying your applications, this is also extremely important. So one we will go into a little bit will be the deployment manager and how that's actually leveraged underneath the hood with Cloud Launcher. And then later on, you'll get to experience a bit more in terms of our services with big data, again, BigQuery, PubSub, and some of the other topics. But if we want to go through and actually just start off with the Cloud Launcher, this is essentially a way for us to leverage a marketplace so you can point and click and deploy environments. This is extremely useful because we not only offer the ability to deploy some of the popular open source tools onto the environment, but also this is a marketplace for some of our partners and some other very popular platforms to be defined and made available. So there are a couple different types. You have the types of services available, potentially deployed to virtual machines. But we also have partners with software as a service offerings and also the ability to do a bring your own license configuration. So we have a lot of functionality here, and the idea is to provide the best practices for deployment and make that available to you, and also to make it extremely easy to get up and running very quickly. So how many people in the room are using SAP? Okay, we have some SAP people in the room. How about MongoDB? We have a few with Mongo. And how many are developers developing with PHP or other technologies? Java developers? Okay, so there are a lot of the things you're already using. If you said you wanted to just try some things out and deploy an environment on the Google Cloud, you'll be able to do that. So let's just start and let's see, we'll do a search for SAP. So we have a couple of options available. And so let's do a live deployment of SAP HANA. So in this set of options, we can see what the potential pricing might be. So with a lot of these different options in the Cloud Launcher, we've defined, or our partners have defined, the shape of some of the resources necessary to get up and running. So in this case, you're able to see what the cost may be, but we also have options when we go into Cloud Launcher to use some of the features you heard earlier in terms of customizing VM shapes and also other types of settings. So as I click into this environment, I can select which zone I'm using for deployment. So perhaps I want to deploy in Asia or maybe in Latin America. In this case, I'm going to leave it in Central. And then we have the pre-configured recommended configuration for 2 virtual CPUs and 13 gig memory. But if I click on Customize, I have the ability to change the shape. So this is a way we can leverage the custom shapes for some of these machines based on your usage and what you'd like to accomplish. Again, we have some other settings, and then what's really useful is that in this initial setup, you also have the settings you need to get proper networking, because we want to have the appropriate security and firewall rules set up and ready to go. So what you typically would need for an SAP HANA deployment has been defined here. So when I click deploy, this is actually leveraging our deployment manager, which is a tool you're able to use for your own deployments as well. So it's not limited to just Cloud Launcher. We have a YAML files where you can define some of the settings. So some of the properties we were selecting in the user interface were also some of the properties you can control and manage dependencies in those files. So as we see this working, I'm going to also bring up our Cloud Shell. So up here at the top right, because this is available to you, you can use some of the command line options mentioned earlier. So you heard about two of our utilities, one gcloud and then one for gsutil. In this case, I'm going to use gcloud, sp.net deployment in place, and then since I had to do this twice, the SAP deployment finished, but you would have seen it running. So let's go and do MongoDB. So we can navigate back to the Cloud Launcher, or we can do the search at the top. One thing really interesting here for MongoDB is that we can select an option Google provides in terms of a click to deploy configuration. And so a Google click to deploy configuration is actually a configuration defined by Google with some additional best practices. So for example, for MongoDB, those of you who are using MongoDB will know that you typically would want to deploy with maybe multiple nodes available. So you have your primary and secondary, and then you have the arbiter. And so in this case, this has been pre-configured for you. So you have a single click to actually deploy multiple VMs. And when we look at the configuration here, so for the servers tier, for primary and secondary, we have 2 deployments. And in this case, we have a bit more memory. We have four virtual CPUs for that configuration. But then when we look at the arbiter, this really is just doing the automatic leader election. So I don't need to have the same configuration. So here we just have 1 vCPU and 3.75 gig memory. So when I go through and do this deployment, it's going to do the configuration for me for all of those different options. So in this case, by just doing a click to deploy, and let me just check here with my online, you can see it in the user interface, but to check in the command line console, I can just do gcloud deployment manager deployments list again. And then I'll see this deployment is currently running. So in this case, we were able to go through, select some options of things you may want to deploy, things that were not necessarily available to you just going by hand, trying to configure the networking and all those other pieces. So we were able to go through and do these configurations in a really short amount of time. So thanks for sitting in on this demonstration. And I'm going to bring back Ria and some of the other people to do a bit more of a Q&A for the first couple of modules. Thank you.
One person in the room thinks it's true, okay? Well, like 4. False. Come on, the rest of you do not have an opinion about this?
Come on. Live your beliefs. Come on. Stick it up there.
That's true. True.
It's true.
It's true. There are some people in the front that are very strong about this. It's true. Oh, it's false. Okay. All right, true or false? All Google Cloud Platform resources are associated with a project.
No. False.
True?
False.
Okay. People are more confident about this?
False.
True. Good job. All right, the next question is not true or false, so whoever knows the answer to it, raise your hand. Service accounts are used to provide which of the following? Anybody wants to give it a try? There, at the very end?
All of the above.
Yes?
All of the above.
All of the above. That's a good rule of thumb, right?
Yeah.
All the way at the back.
Okay, by the way, when you take the certification test and you see a question like this,
All of the
it's
above.
usually all of the above. Don't tell anybody. Just between us.
All right. Who has questions? How can we help answer any questions that you have? So there are microphones on either side of the stage. Come on up to the mics and we will answer your questions. By the way, these are some of the resources that are available to you. We will share the slide deck with you, or it's already been shared. So you should have this.
Wow.
Hi there.
Hi.
Quick question. You guys haven't talked about dedicated hardware. When I create a container, and if some other tenant is running a different container, but it's using a lot of CPU, like I've seen on other clouds, your performance may be significantly hindered.
They know. Don't ask me
There
how
is
I know they know.
intelligence built into it.
Yeah, they literally, first of all, there's no, you aren't interacting with a hypervisor. You're about 4 or 5 layers above it, layers of containers above it. So the container infrastructure is monitoring that for you. So the containers themselves are instrumented for CPU, for network. And they would be the first one to detect noisy neighbor. On the first one, is it just exploration of use case? Is that specifically your use case, or is there like a regulatory constraint for dedicated hardware?
No, just coming from running high performance web applications, I've noticed that all virtual machines have large variation of latency. And we've only been able to reduce that after moving to dedicated hardware, which we were in charge of. But as soon as we were on a shared environment, it was all over the map. And I'm not talking about GCP, by the way,
Right.
different cloud.
Yeah.
Thank you.
Hi. I had a question about the YAML file that Corey was talking about. Is that only specific to the environment that you're deploying, or can you actually cobble together multiple YAML files and make one big YAML file to make a larger multi-service deployment?
Yes, you can. It's called the Cloud Deployment Manager. Roughly equivalent to CloudFormation or Terraform. So yes, you can create an ornate system completely described in a YAML form through cloud deployment. Thank you for being patient, sir.
No worries. Actually, I have a more high-level question. Since we talked about roles and setting up the permissions, if we start a new Google Cloud Platform-based infrastructure or service, do you have best practices in terms of how should I assign developers versus QA versus DevOps? You know, looking at the available permissions and kind of the root access controls, there's a long list, you know, edit, view. I don't want to drill down that deep. At the same time, looking at the predefined ones, I didn't quite see how I could utilize them because they seem to be associated to the instances. Whereas I'm thinking, you know, we're going to make use of multiple instances across your services. So what are the best approaches in setting up a new organization?
So the short answer to your question is we do have best practices available, and when you get started on Google Cloud, we will have what we call a technical infrastructure kickoff, which is when our team will come and help you with how do you organize projects, how do you assign roles and responsibilities, how is your network going to be, how are your IAM privileges designed, and all of that. So we'll walk you through a full day of processes where you bring in your enterprise architects, your security professionals, and your developers and product managers to design the whole system.
I can give you a customer, I guess, example. I mean, we have customers, large enterprises, they'll break them up by projects, by line of business. So each line of business has a project. Within those projects, you have different roles, QA, like dev, test, and development. Those could be, you know, more projects as well. So it really depends.
Customized? Are they all customized roles that you create from scratch?
No, there's default roles, but we give you the granularity to make it very customized if you want it to be.
I saw that, which is very granular.
Oh yeah, very granular. But we have default roles too that I think for most customers make sense.
And in terms of like a end-to-end CI type system, would you recommend creating projects for each environment? So dev, test, staging, production?
No.
Yeah, I think we really have to understand the workload and even understand your organization. Depending on how your organization works, you might have different billing per each group, and kind of complicates things. If everyone's in the same group, you could have a whole CI/CD environment within one project. So it really depends, and I'd be
Can we
happy
up
to talk
and
to you
go?
offline. Yeah.
Can we get up and just go?
Oh yeah, it's okay.
Hi, so I
like-
run now on WordPress, a couple WordPress.
There's a couple of ways of doing that. You could use the G Suite directory connector, and it just treats not only AD but LDAP as identity store or as source of truth about identities, or any system, and AD as a service supports this, any system that supports OAuth authentication. So as long as AD as a service is willing to provide the 3 calls for OAuth, we're good to go.
All right, so I think with that, we will.
I have to figure out CIDR and, I did the /20, I should have done the /16, that sort of stuff. A Google Cloud Network is fundamentally different, the GUI address. So we see here that when we declare a network in the Google Cloud, that network spans the entire world. So you have one network. That network can have entities in Europe. It can have entities in Osaka. It can have entities in Sao Paulo. It can have entities in Oregon and Virginia. Regions become subnets within your network. So we have, in this case, we have 2 subnets that have been created in US East. Sorry. We're going to circle back to this and talk more about this in a little bit. But what I want to emphasize here is in this case, we have one subnet that is spanning all the regions in a particular region. I'm sorry. It's spanning all the zones. Sorry, flipping technology in my head. Don't say the A word. Don't say the A word. So this one subnet crosses all the zones in a particular region. So you automatically have high availability and fault tolerance within your network structure. You don't have to construct your network to support that. So I'm just going to set that as a bookmark right there. We will circle back to this. So now let's talk about the compute engine itself. Note that we are being careful not to talk about virtual machines. We kind of do in order to set the context, but these truly are not virtual machines. In a classic sense, a virtual machine is a guest operating system that was booted by the hypervisor and is essentially one layer away from the bare metal. Within Google, as I mentioned before, you are multiple layers away, giving Google the flexibility to move your entity around it just about anywhere, because it's just a container. Google has been 100% committed for containerizing its entire workload for well over a decade. So these are managed virtual machines. They come in some standard formats: high CPU, so the higher percentage of CPU versus memory; high memory, standard shared core. You have the ability to create persistent disks. I'm going to use some AWS language here. That you have the ability and the equivalent of EBS. And with EBS, as with the EBS, you have your choice of connecting over a network to a disk service that is providing you this disk-like thing. You read to it, you write to it, the operating system doesn't know any better. The 2 different kinds of disk available: spinning disk, in this case referred to as standard, or SSD. One thing that's unique about about Google is that the local storage is under your control as well. You can create local SSD volumes, in other words, physically attached to the machine that your VM is running on to improve your throughput. So this was in reference to the question earlier. If you wanted to have a database server, you would obviously optimize it with local SSD. In addition, the persistent disk can be snapshotted, and these snapshots can be done at any time. You do not have to quiesce the disk. You should, because at the operating system level, Murphy's Law guarantees you'll be writing a file. But you do not, for example, have to halt reads. The disk can be resized, it can be resized with no downtime. And then the VMs themselves contain what we call instance metadata, description of the environment that the machine is running on, and startup scripts and shutdown scripts. So, again, using some AWS lingo, metadata plus user data, with the addition of being able to invoke a script when the shutdown signal is received. As we mentioned before, we've got per second incremental pricing, preemptible instances. So these are instances that automatically come with deep discounts, so you don't have to bid for them. You have insanely high throughput. Depending on the size of the machine, you have up to 25 gigabit per second throughput to storage. So you do not have to configure your machine with special or add-on cost in order to get high I/O rates to your machines. And as I mentioned before, you can customize these things. Your machines can have 1, 2, or any multiple of 2 CPUs, and the same applies to, or similar rules apply to the memory. Okay, so rolling back to the VPC network. If you remember, I said that the network is created, spans all the regions that GCP exists in. What it gives you is the ability to create really, as Omar mentioned, you don't want to treat your security like an egg. You don't want to build a castle wall and forget to put locks on the bathrooms. You want to make sure that you have layers of security so that people have to get through them in order to access the valuable stuff. People who attack my systems, I compare them to rats, which is bad because I really like rats. But if you know anything about rats, rats can chew through anything. Rats have been known to chew through quarter-inch steel. They are dedicated. The only way to stop a rat is to create enough barriers to slow them down so you can detect that it's occurring. And again, I have a much higher opinion of rats than the people trying to break into my system. So you're going to have fine-grained networking policies that allow you to specify who and where is allowed access. You have IP address range selection, and this is innovative. You do not have to have consistent IP addresses within your network. So it's not like you declare a network to be 10.0.0/16, which means that every IP address has to start off with 10.0. You can have a subnet that's 10.0, you can have a subnet that's 192.168, you can have a subnet that's 172. Every subnet can have its own IP address range. So the IP address range then become a layer of security. So you can create routes. If someone's coming from this particular subnet, they don't have a route to get to the HIPAA data subnet because we just didn't publish a route into that subnet. We also have firewalls. The firewalls have very fine-grained abilities to them. We can create virtual private networks. And within the VPC network, we have an entity called a cloud router. Sorry. Okay, so stepping back a little bit, how do we connect to these networks? If we want to do a very high speed, highly secure interconnection, how do we do that? We've got a couple of ways to do that. Google has partnered with enterprise, with entities like Level 3, EXO Communications, Global Crossing, to be able to provide interconnections to things like your data center. If you have equipment, there is now the really interesting one here, load balancing. If you are looking, if you have multiple websites around the world, and they are sitting in different regions around, access to these websites via cloud load balancing. And what that means is that the request for your website from a user will go to the nearest point of presence and automatically be routed to the closest least latency system provided by you. The load balancing occurs at the HTTP level. It requires no pre-warming for sudden bursts of traffic, and it is a single IP address for worldwide connectivity. So just like Cloud DNS, the cloud load balancing system uses Anycast. Then there is network load balancing, where if you have to do something like you have to host the actual SSL certificate for an HTTP, that would be a regional product, because we can't use Anycast in that context. So a network load balancer load balances across web services or TCP services or UDP services that are located in a particular region. Again, requiring no pre-warming. Then, in terms of getting the content to your user faster, as Omar mentioned earlier, our users are becoming more and more demanding. 200 milliseconds is 0.2 of a second, and people are willing to abandon a website because something hasn't redrawn in 0.2 of a second. Seriously, get a grip. But you may have those kind of constraints. One of the ways to get around that is obviously the speed of light is a limiting factor. So we're going to push our content closer to the user. We can do that with the Cloud CDN, the Content Delivery Network, so that both content going out to the user and input from the user can be stored in the CDN and be reacted to much more quickly. With that, let's do a quick quiz. See if people survived lunch. So name 3 robust networking services available to your application on Google Cloud Platform. Okay, first of all, whenever we use the word robust, who wrote that?
Marketing.
Not an engineer. Robust? How do I quantify robust? So anyway, what are 3 robust networking services? HTTP load balancing? Yep, CDN? DNS, there we go. Okay, never mind, we've already seen this one before. If you can't answer that, you have no pulse. Okay, true or false, Google Cloud Load Balancing lets you balance HTTP traffic across multiple compute engine regions. Altogether? True. Okay, so there's some of our resources there. So what I'd like to do now is bring Marco Amani up, demonstrate some of the capabilities of the Google Compute Engine.
Right in your browser, you don't have to have Unix or anything installed. If you're on a Windows machine, you don't have to mess around with PuTTY or anything like that. So right here, I'm going to create my own little directory. So let's call this demo. Very creative name. And then I'm going to bring down a copy of this template, right? So this is downloaded for me. If I look at it, the material's there, so I'm just going to CD into there. So as you can see, there's, it gives me a README file and a bunch of files under dub. So the easiest thing for me to do now is to grab a YAML file, and these, you can find them very, very easily, and they're super easy to make. So we have one of our documentation pages. I'm just going to copy out of this because it's just so simple to use. And as you can kind of see, it's defining my environment. It says I want a Python 2.7 environment. It gives me a couple of handlers, and it just says, the root of my application is going to dive right into my dub folder, and it's going to be my index.html file, right? And it also specifies that I need to upload a ton of other files under the dub. So pretty much everything under there, right? So that includes my images, my style sheets, and whatnot, okay? So here, you're gonna watch me use Nano, not Vim, and don't hate me for this, but I'm gonna do it. I'm gonna be brave. Here we go. So I'll write this file out and get out here, right? So now I have a YAML file and I've got my files. And really, all I have to do is say gcloud app deploy. If I can type right, here we go. So this looks at my YAML file. It looks at my files. There you go. It says, where do you want to deploy this, right? So I can pick where I want to deploy it. I'm going to use, let's see, I'll use US Central. How about that? So as you can see, I'm not messing around with any servers. I'm not playing with load balancers. I don't have to care about the network, how it's set up. Heck, I don't even have to worry about disks or if it's an SSD or regular hard drive or anything like that. I don't have to worry about backups or anything like that. It's just deploying this for me. So it's going to upload my files, and it's going to spin up my application. So this is a brand new project. I haven't done this in this project before, so it's kind of doing its thing. Yep. You can see it uploads 57 of these files to our storage platform. And within a few seconds, it'll be done. Sound easy enough? I think so. Okay. So once it's deployed, we can take a quick look at it too, see what it looks like. It even tells you, it says you can type in gcloud app browse to view your deployment, and it gives you a nice little link. So I can click on this, brings me right here. Okay, this is very simply deployed for me, and I don't really have to put a whole lot of thought into how it got deployed, right? I just brought my code in, if you will. So let's say I really like this, and I think this was a good deployment, right? I liked it. So I'm going to version this. So I'm going to give this a name and call this is my blue website. Okay? So it kind of goes through the same process, but this time it says no files to upload because nothing's changed really, right? The code base is exactly the same. Kind of does its own thing again. And while this is going on here, I'm going to click on this little drawer. I'm going to go to App Engine and go to my App Engine versions. And as you can see, this was the previous version. I didn't give it a name, so it kind of randomly generated a name for me. It's really just a date and time. And then now it has this name for me, and because I called it blue. Again, I can click on this, it takes me to my website. This is the latest version of my app or my website, okay? So now let's say, my boss comes to me and says, hey, Valentine's Day is coming up in 2 weeks, right? It's coming up in 2 weeks, I think. Tomorrow? Oh, I gotta go. My wife's gonna kill me. So you guys, no? Okay. So let's say, something's coming up that you really have to, change something in your website. So I'm just gonna run a quick find replace. I'm gonna change all the colors on the site from blue to red, okay? And that's all I have to do. So I just type in the gcloud app deploy again. I give it a new name. This time, it grabs all the files, and it says, okay, 6 of your files changed, probably my style sheets, right? So all I did was change the color, really. If I refresh this in a second, you'll see that now I'm going to have a new version of this application. Here we go, that's done. And this is taking care of load balancing traffic for me in terms of how users are hitting this app, the previous version of the app, and how they're all going to get balanced to the new version of the app. Again, I didn't have to set anything up. There was no DNS involved, nothing like that, right? So now I'm going to refresh this, and watch. Now I have the red version of the site, right? I can click here. Oh, my replace probably didn't work. Well, let's see if we can do that again. So this is the color code I have. I got to live demos, right? 2196 F3 I think is blue, and then F44 242 is my red. Wonder why that didn't go.
11.9's durable mean. If you put one file per second for 3,809 years, you probably will have lost one. better deal with that. And by the way, what were you doing 3,809 years storing files? In order to do that, there are some things that storage imposes to make its life simpler and to make the ability to do things like replicate easier. So one of the things you need to know about Google Cloud Storage is it is not a file system. It is not a mountable disk. Everyone comes up and goes, that would be a great mountable disk. No, it would suck. Because it's meant to be a thing that absorbs binary objects and holds them for you. Binary or text objects or whatever. It absorbs an object, holds it for you, making that object available to you, the ability to store it and retrieve it over HTTP. And that makes the nice thing about this is it's universally accessible. Anything that can make an HTTP call can interact with what you have stored, provided you gave the right permissions. So it has one level of storage. You put objects in a bucket. And within that bucket, you can put as many objects as you want. Essentially, an unlimited number of objects. The objects themselves can be up to 5 terabytes. Meaning, in 5 terabytes increments, you can have unlimited capacity. So the backups that you're having to save from 30 years ago. Anyone in the pharmaceutical industry? Okay, data retention. You have to retain records of drug tests for a minimum of 35 years, correct? Or for the life of the drug. What were you storing data on 35 years ago? I don't know about you, but it flopped for me. And it was this big, right? And if you got the really, really hot machine, it got down to that big. Anyone here have a floppy drive at home? Of course. Okay, civilians, the trouble with storing data, there's a fabulous book, 100 Years of Solitude, where covering the life of a mythical village in Colombia. You didn't know this was going to be an English lesson, but it is. But there's a whole chapter on what they call the disease of forgetting. Every morning they woke up and they forgot everything about the village. And so they went around labeling everything. And then they forgot how to read. And you laugh at that, but there are tapes sitting in if your enterprise is 30, 40 years old, there are tapes in your archives that you cannot read. True? So that's what this object storage is meant to be. An ability to throw objects in and be guaranteed that we can retrieve it at some point in time, assuming Google survives. But you can also take it off at any time. So, as I said, this is a binary large object storage. It is encrypted in transit by default. It is encrypted at rest. You do not have to encrypt it yourself. Google will encrypt it. So if someone gets a hold of the disk, it's useless. You can also, so these are keys that Google manages. You can substitute your own key and just have that extra level. What I suggest you do, though, is encrypt it on your side, on the client side, with your key. Then copy it over and let Google encrypt it at rest on the Google side. So you've got it all goofed up. Another thing you have is the ability to have very high capacity transfer into the Google Cloud Storage. Or you can work with Google Cloud vendors who can move it for you. A bucket as being multi-regional. You pick a continent, like US, Europe, Asia, and you say create a bucket there. What happens then is the bucket is replicated across every region in that continent. So your SLA goes up a bit, but you also don't have to use a CDN. It is slightly, like 0.3 cents more expensive to store it in a multi-region bucket. You can also have regional buckets. If you are storing data, for example, let's say you're in life sciences, you're doing a DNA analysis and you've stored a genome analysis, you've got a whole bunch of genetic data that's sitting in a bucket, put your processing in the same region. What that will do is decrease the latency, because Murphy's going to get in there and divert the call from, if you're in Virginia, divert it to Oregon. Make sure everything's in Oregon. It'll be slightly less expensive to run. If you don't need this data, let's say this is a backup and the backup's gone, it's a 30-day-old backup. You tend to use backups immediately or very, very occasionally. The immediately is very near term. Very, very occasionally might be something like, oh yeah, Mr. Auditor, I can prove we have last year's backups. So anybody who isn't personally affected or at some, or knows people who are affected by autism. It's a mysterious condition. It's the problems associated with it really test the family structure, and is something that we would like to get a hold of, like to understand more, but there is no obvious link right now. But researchers are trying to understand better about possibly genetic factors. The trouble with DNA is it's the ultimate PII. I can't, if you have a sample of my DNA, I can't deny that it's me. No, I didn't sign that correctly. No, it's my DNA. So it has to be protected. So Autism Speaks uses Google Cloud Storage as a transfer method between researchers, and has created a HIPAA compliant, not only HIPAA compliant, what's called GINA. GINA is a higher level classification for data, for DNA data. Both of those Google Cloud Storage is completely compliant with. So we're letting the testing work better, having this data bus with Google Cloud Storage. Okay, so let's move to a different kind of scenario. Storage, Google Cloud Storage is storing objects for us. Cloud Storage, your entire text is sitting in Gmail. So we're sucking in all this data, and how many people, we know from this morning that over 1 billion people a day are using Gmail. So Bigtable has the capacity to do that. It is integrated with HBase, as you saw earlier. Bigtable, the Bigtable paper caused HBase to be developed in the Hadoop ecosystem. So why would you choose it? Replicated storage, data encryption, flight in at rest, but the most important thing is if you have high volumes of data that has to be captured reliably, immediately. So I mentioned earlier that Bigtable has the ability, or has been shown to have the ability, to capture trades as they happen in the New York Stock Exchange. SunGard is a financial company that used Bigtable to do a proposal system to monitor trades in the New York Stock Exchange as they happen. You might have heard about something called flash crash, where a company called Night Trading reversed some trades and caused the market to lose $3 trillion in about 100 seconds. That was bad. And the New York Stock Exchange reacted with, well, how do we monitor that? And SunGard used Bigtable to demonstrate that Bigtable is capable of doing that. That was a big effort in the previous administration. Who knows? Okay, so access patterns for Bigtable. It is a no SQL system, so obviously, you're not gonna be using SQL for it. You're making API calls to add, delete, update data within Bigtable. So you can do it through the application API, you can do it in streaming, or you can use it as a batch processing system. So let's say you've got sensors scattered around the freeways of the Bay Area, and as is typical with the Bay Area, the sensors are recording no speed above 20 miles an hour. But all this data is coming back to Bigtable, so Bigtable can capture it real time, and then in batch every minute, display what's going on the freeways. Of this capacity with this much disk, and 5 minutes later you've got a server, you've got a JDBC endpoint, and you've got a database server. I don't know how many years of my life, Spanner, it doesn't. Spanner seems to violate that rule by saying this is a global database that provides consistent data within agreed upon timeframes while maintaining availability and partition tolerance. And in any week, 80% of Google is interacting with Spanner. So you have, and it's currently limited. based on data governance and such, it's currently limited to continents, but eventually you will be able to have Cloud Spanner, have people in Singapore updating order records that get reflected in Shenzhen for packing the containers, and updates Oakland as to the time when the container is going to arrive, all in real time. Because Google's doing that right now. Okay, so, and because it's SQL, there's no change in your infrastructure. Someone from finance, and it's always someone from finance, comes along and goes, I want to read the database from my Excel spreadsheet. Okay. It's supporting JDBC, it's supporting ODBC, it's supporting SQL standard. It is SQL 2011 standard. It just happens to be a global database. So circling back to the other side of data store, we have Cloud Data Store. Cloud Data Store is again a NoSQL system, but it's built for transactions. It's built as a web-based data storage system. So when I say something has a transaction, what I mean is that you declare a series of commands as a transaction. If the commands succeed, you are fine. If the sequence of commands is not fulfilled, the database is restored to the previous condition. So it's something that could support things like e-commerce. Did the credit card go through? That? Yes or no? If it didn't, rewind. It has choosable consistency. So you at the application level can say, I'm looking up a price. This darn well better be consistent. Versus, I'm just feeding a dashboard. Meh, give me good enough. It is also built in redundant across the region. So it has high availability and fault tolerance built into it. It also, and you knew this was coming, it has a free level. You can do 65,000 transactions per day for free. It's beautiful. So cheap. So the benefits here, local development tools, your team can be working on their systems using consistent calls that you then export into GCP. That free quota I talked about, because it has a RESTful interface, you are not limited to any particular API. You can write your own API to it. So the various storage options, Cloud Data Store, where you need transactions, but you don't want the overhead of running an SQL or relational type model. Because of the way BigQuery stores data, it doesn't have the ability to insert and update quickly. So, use cases, data store, app engine transactions, web services, transactions, big table, every service there is. For the VMs, that's where your operating systems are located. It's also where your metadata gets located. It's also where your startup scripts and shutdown scripts get located. So it acts as a data bus for just about everything in GCP. Bigtable integrates with other services through things like Dataflow. We'll talk more about that in the last module. Dataproc, which is Google running Hadoop for you. Or if you have the Hadoop ecosystem running, you can run your MySQL Postgres database and access it from your data center. You would just create firewall rules. I want to hear it in harmony. Beautiful.
Nice job. You stream huge amounts of data from devices with sensors. Which storage would you use? Bigtable. Wow. There is no food coma here. What are you talking about? Okay, more resources. Q&A time. For those of you that did not get an opportunity to ask questions during the last Q&A session.
Running. App Engine is sweet. But there's probably a middle ground when you're going to need to have components of your system that come into and out of existence, that need to load balance. If you're breaking monoliths down into microservices, the easiest way to approach that is to take your functions and devolve them. And say, okay, if I'm going to call login, rather than having a login function within my monolith, I'm going to go call a login API call. And if no one's logging in, I can spin down that capacity. So this is where we are with something like Kubernetes and containers. So why use containers? Well, containers, throughout my career, the holy grail was write once, run anywhere. And I think we finally nailed it with containers, particularly since containers are now native to Windows 2016, or Docker's native to 2016. So if I write something on my Mac, I put it in a Docker container correctly, it can run in a Windows environment, Linux environment, on someone else's Mac. The other thing is that by containerizing stuff, by breaking things down, I've created what's called loose coupling. Rather than me making a call to this login function and being aware of all the error states of the login function, I'm going to call a login service, and this login service is going to tell me a successor failed, and if it failed, it's going to append a description of the failure conditions. So the login service then can be changed. You know, it could start off as username, password, and then I could go buy Okta and create an SSO system, or I could interface it to some sort of identity store. The API that I'm calling has no change. Your API is your contract. What's behind it could be Okta, it could be squirrels in a wheel. Doesn't matter. The other is obviously workload migration. You know, no longer coming across the table. If it worked fine on your box, it'll work fine on my box. And agility. So what containers actually are versus virtual machines is that a virtual machine starts up and says, I'm the machine. You make a call to the disk drive, I'm the one in charge of reading and writing the raw disk. The hypervisor is faking it out, but the virtual machine doesn't know that. With the container though, what we're saying is this is running within the operating system itself. If I need to read and write the disk, I'm going to ask the operating system to do it for me. So Docker, in this context, has this little shim layer that runs on Windows, it runs on Linux, it runs on my Mac. When I make an I/O call, the shim layer translates it into the native operating system. The advantages being, doesn't matter what platform I'm on, I get incredible fast startup. And my processes have no awareness of the environment that they're in. The problem with this is, once you get beyond a couple of containers, or maybe you have containers that come into existence, out of existence, or need to scale, it becomes beyond human capabilities to stop and start containers. If human fingers are making any changes to the infrastructure, you are doing it wrong. These here, these are my digits of doom. These have caused more pain than you can imagine, because they get in there and they do things like add zeros, remove 10 machines. I think you should remove 10,000 machines. Your fingers, we human beings are horrible at doing the same thing the same way every time and doing it again and again and again. We get bored. You know, the factory lines that you heard about where a car would come, you reach out, turn a screw a quarter an inch, and you do that all day. What we are good at is pattern matching, is problem solving, is taking the meta condition. You know what machines are good at? Machines are good at being machines. So what we want is some sort of machine, some sort of API that can take care of, hey, we need some more containers. Or, oh my God, the machine the container was running on has disappeared. I may need to restart those containers. Google's answer to that is Kubernetes. Kubernetes is Greek for helmsman. That's why you see the ship's wheel. That's all the Greek I know. Automating deployment, scaling, open source. It's, as I mentioned before, internal to Google, it was called Borg. Google released it. It helps maintain it, but half the maintenance is occurring in the outside world. It is built, by the way, for a multi-cloud world. it already has the ability to say, well, I don't have enough capacity here in GCP, but you got a couple of spare machines back in the data center. I think I'll use those, if your rules let me. So what you get with Kubernetes is intelligence about things like, will this fit here? Or do I have enough resources to run it? Load balancing and auto scaling. So that's Kubernetes. And you can go to kubernetes.io, download it, and run it yourself. But besides free, what am I? Lazy. If I can have Google do it for me, and they're pretty good at it, I don't have to spend time looking up in the manual, setting things up. I can just set up the Kubernetes engine and have it work for me. So the Kubernetes engine is a fully managed cluster management system. In other words, it takes care of starting the machines that we're running on and orchestration, which means this container should go there. These containers talk to each other, so they should be deployed as a pair, those sorts of things. It allows you to create rules for all this in a declarative syntax, and you literally do a Captain Picard. Write out the commands and say, make it so. No nerds? Okay, why use Kubernetes? Well, actually now it's because everybody's using Kubernetes. Kubernetes 1. Kubernetes is pretty much the standard for management of containers. But you obviously can use Kubernetes engine to integrate it with GCP. Things like the logging, things like health management, and Google is committed to maintaining compatibility with the current release of Kubernetes. So Kubernetes engine's deployment schedule is being driven by the outside world. That's a heck of a commitment. So we have complementary services, services that help you run Kubernetes. When you describe the Docker container system and the Docker registry to your security people, what's the first thing they do after they recover from their heart attack? I believe the word heck and no is included. Because by default, if you're going to push a container, even one that's private, it goes to Docker. But specialize in taking legacy Java and moving it to the GCP. So Java code that's 5, 10, 15 years old, they specialize in being able to move it directly onto GCP. And obviously they're using containers to do it. So Kubernetes engine versus App Engine. Big thing here is Kubernetes is just running what's in the container. The container could be COBOL. It could be running the IBM 360 operating system emulation, if you're really into self-abuse. Think about all the old operating systems. Anyone remember CPM? You could run WordStar inside of a container. There's like 3 people going, cool. The service model here is a hybrid. The idea that we don't care where it's running. And the primary use case, obviously, container. So with that, let's do a quick quiz. What are 2 reasons for deploying applications using containers?
Not fast.
Speed.
Speed.
Yep. Anything else?
Speed.
Well, that comes with Kubernetes.
Separate infrastructure from the development.
Exactly. Your environment is decoupled. True or false? Kubernetes lets you maintain container clusters in multiple cloud providers.
True.
True. Okay, true or false? GCP provides a private high-speed container image storage service for use with Kubernetes engine.
Yes. True.
Excellent. Okay, so
Whack-a-moles here, and I'm sure everyone's played whack-a-mole before. Instead, let's treat those as applications, right? We've declared that we're going to have 2 of them, and no matter what kind of occurs, this could be bugs, this could be node failure, this could be some type of downtime, we see that the moles keep popping up, and that's what Kubernetes does. It's always driving us towards our desired state. And so declarative programming is just, it makes operations so much easier when we're able to just declare how many replicas of our application that we want, where that container that's being used for the replicas or containers are living, what kind of storage, what port I'm exposing, and that's it. I throw it into Kubernetes or to the Ether, and we see that it's running, right? No more messy type of port mapping that maybe you're doing with other orchestration tools. It's really just all about being able to declare things in an API and being able to have full faith that it'll be deployed and that it'll be resilient, always driving towards that desired state, even in the case of errors. So just quickly, whoops. So this is just again, kind of a very high-level architecture of what we're working with Kubernetes. We have developers and operations who can interact with a control plane, also known as the master, and that has a set of applications running that will ensure that these containers are deployed across a set of VMs. And what's amazing about it is that in this architecture right now, I'm only showing you 3 distinct nodes. But we've seen that Kubernetes can scale up to hundreds, if not thousands of nodes to support a set of services. And so that's really great in the sense of being able to kind of depend on that consistent environment at a small scale or at kind of, we're talking Pokemon Go levels of traffic coming to your application. So I'm going to quickly show this a little bit here. So this is a cool little kind of game that our developer relations team has built called Whack-A-Pod, right? And so again, this is really just what I wanted to what I wanted to drive home is the resiliency of it. Each of these little moles represent an application, and as I take them down, we'll see new services or new replicas step up to take their place. And so you see that Kubernetes is always driving your desired state. And so, while I do want to show kind of the carnival thing, I do want to show a bit of a more advanced view, because we mean business here, right? So what you're seeing here is the same 12 replicas, and these were, rather than being represented by moles, we see that they're now represented by green circles. And so as I kind of click on each of these, we'll see that Kubernetes understands that I've given it the desired state of 12 replicas. And so my cluster here has 2 nodes, and we see that as I continue to kill some of these pods, we see that new pods are spun up in their place. And again, the last thing that you want to do is ensuring that all of the proper dependencies are aligned and installed on the server that you're running on. Rather, we just package it up into a container, give it to Kubernetes, and it doesn't matter what machine they end up on. It'll run and function as intended. Again, even in the event of node failures, I actually drained this entire node on the right, and we see that all of the replicas were moved over to that other virtual machine. And what's cool about Kubernetes is, at scale, that's really awesome, right? And even if we're out of resources, Kubernetes can recognize that we have more containers pending to be scheduled, and it'll spin up more virtual machines to actually handle that, independent of any action required by you. So the last thing I do want to show, or not last thing, a couple more things I want to show. So that kind of Whack-A-Pod application is actually just a web app running on Kubernetes. But I want to open everyone's minds up to the idea that Kubernetes is really getting a lot of traction for more than just kind of stateless or web app types of applications. We're actually seeing it support a lot of different, pretty much anything that can be Dockerized. And so what I'm going to quickly show is that we have the ability to run a job that will calculate the value of pi to, I think, 1,000 digits. Let's see here. So I have a little cheat sheet. Does anyone do live demos here? Anyone? I've been burned several times before, so also apologies for using nano there. I was trying to hide that. All right, so let's see what we have here. So if I look into the cheat sheet, so yeah, I really want to show that Kubernetes is not just meant for kind of stateless tasks or front ends or business logic. We're going to display another construct in Kubernetes called a job. And so a job is something that runs unto completion, and it can run unto, I'm only defining it as calculating this value of pi once, but we can actually do this multiple times. So you can define a job to run to completion, let's say 10 times, right? And so this could be, oops. So I'm creating this, let's see if everyone can see that. Oops, nope, that's not working. So as I create this job, a container will be deployed into my Kubernetes cluster. Oh, just kidding. Actually looks like I have invalid YAML. But I'm not sure I have time to fix that right now live in front of everyone. But what I do want to show is that while this kind of job that I was going to create is useful for calculating pi, people can use it for database migrations, seeding a specific database that you're running in a Kubernetes cluster, or even machine learning training, right? The use cases of Kubernetes clusters, the kind of benefits that it brings span multiple different types of use cases. And so the last thing I want to show is why Google Kubernetes Engine for Kubernetes. So if we look at here, again, in order to have a functioning Kubernetes cluster, if we look back at the architecture, there are a lot of different components that you're having to think of at the control plane layer, right? We're having to think of having our API server up. That API server, to be able to create these resources that run our containers, we need to have a data store, right? So that's a data store that is storing our app state. Some of that application state is secrets, right? How do we securely store those and manage those and transfer those into the containers that are pulling those credentials, right? All of this is stuff that, Kubernetes certainly gives you the levers, but at scale, and especially with, let's say, a smaller operations team, comes with its own operational complexity. What's nice about Google Kubernetes Engine, which I'm showing you right here, is that all of this is taken care of for you. So the Kubernetes control plane is actually managed in a Google project by our SRE team. So that includes, secure TLS from master to all the nodes running your applications. That includes encryption of secrets, right? And so that's really the benefit here, is that we're able to take, again, from the UI, just a few clicks and flags and buttons, and we have a functioning Kubernetes cluster up and running. And the last thing here is that we have node pools as well. So we don't only have management at the control plane layer, which ultimately to me is table stakes for Kubernetes, but we also have several advanced node features where we actually can dive in, we can upgrade our node versions for security reasons.